Hi everyone. So, funny story. I'm going to switch over to this thing here. Funny story. Yesterday I recorded the entire lecture, all the various parts. The actual demo worked out well. I was very proud of I hit all the points I wanted to go over. Had some screaming kids. I thought it was fine. And then I looked at the video last night and realized, oh, the CPU had been hit so hard that all the videos were ruined. You couldn't see me. I would just that sort of thing. So as a result, I have to re-record everything, which means I had to roll back all of my old code. It also meant that I had to do it while my kids were not underfoot, so I'm doing it at night. And since they're taking up the room where I normally record my videos, you are now in the Fortress of Solitude down in the basement of my house, in case you're wondering why the lights all look crappy. When last we left her here, so I always do a lot of D&D with my boys down here. When last we were looking at this, we looked at WLinkedList, and we didn't do it all the way through. I just did up to a certain point. I was playing with so we have our linked list we already talked about. When we went to our WLinkedList, I didn't really implement most of the code. In fact, I left a lot of this stuff out on purpose. And then I said we're going to go and revisit and we're going to fill in the various functions that have to be unique for a doubly linked list compared to a singly linked list. I'm going to keep on doing that. I have made a couple little tweaks along the way. One of those tweaks I wanted to warn you in advance for is with our linked list.h. When I started working the code yesterday, I went, oh, that's so much better. And then, promptly, we're not going to do that. So let me see here. Where is it? Insert it back, insert it front, remove back, remove front. Insert it front. We have a special new version of insert it front. It's a protected version of insert it front because nobody other than a linked list should be using this, either a doubly linked list or a normal linked list. This is a special version where it takes in a linked list node and inserts it into the list at the front. We have this because we're going to keep on sort of hitting that particular scenario. And if you want to see what the code looks like for that, hopefully linked list get index. So I have insert it back, insert it front. Here's one version of insert it front, which takes in our data that we would normally do. And all it does is I make a new linked list node, and then I insert it at the front. The reason I want this is because I'm going to need to have a different kind of node when I do my doubly linked list. We'll get to that later. So this just then finds if the start is there or not, and if there was a start before, so if there is a start, then I have to I put that to the front of my entire linked list, and then I set the next to this starting point. Otherwise, I have an empty linked list, but it doesn't really matter. In both cases, I want the start to be this new node I'm adding. Okay, we'll have to do one other little tweak for insert up front for our doubly linked lists. So, and I'm going to put some IOUs along the way here. So, our normal constructor just sets up the one new variable that I have. I'm going to automatically call the the parent version of the linked list class constructor, which is the parent class, before I do the child version. And we will actually see this. That's why we put these cout statements in here, just to say, hey, look, this is the order these are coming in. My destructor, same thing. I'm doing printout statements purely for me, so that I can show you, or further for you, I guess. So I can show you how the destructor is called. It's going to call my own destructor, and then I'm going to call the parent's destructor at the very end. I have to do it in a particular order because the parent can't know anything about the child, essentially. Okay, so insert at front. What could I do for inserting at the front of my doubly linked lists? Well, I have two different problems here. I may have an empty doubly linked list. If I have that, then my pend is going to change. Otherwise, pend is not going to change at all, and I'm just going to insert it at the front. Okay, so that works out well. I'm going to make a we're going to have to visit this one again. LL node. Hopefully I didn't get rid of my LL node everywhere. It is missing from here. There we go. Knew it looked a little off. There we go. So I'm going to make brand new linked list node. What do I normally call these? New node. Okay. I'm calling it new node at least for this time. And then I have new LL node and then to add. Great. And then what I'm going to do is I'm going to call insert at front and p new node. And the only reason I'm not calling the other version of insert of, oh, and I need to, it's going to be the parents version of this. So this is how I indicate the parents version of a function. I say, yeah, not just the normal linked list node. I'm calling the parent one linked list : the one for the linked list, not mine, the parents version. Okay. Once I've done that, I also need to figure out, I'm going to need one other thing here. I'm going to have to see if, let me see here. I forget the name of the function, so is empty. That's what I really want, right? If I have an empty linked list, I forgot the name of the function, so actually I think I did know it, but when I forget, or if I have a little, if I'm not sure, I can use the this pointer just to give me this autocomplete. So if it's empty, then p end is equal to p new node. Why? Because I still need that end to point to something. When I insert the very, very first node for the entire linked list, I need the p end to also be there. Okay, and then I insert at the front. Okay, that should be fine, I hope. Okay, how about inserting at the back? Okay, that's going to be a bit weird because I'm going to need to know what the previous is. I'm going to have to put some IOUs in here, or to-dos. So I'm going to do the same thing as I had before. I'm going to make a brand new linked list node. I need to figure out if there's not anything already in my linked list, and this is, I'm going to pretend that I've just discovered this. This is what I discovered yesterday. If I have an empty linked list already, I'm saying insert at the back. It's the same as in saying insert at the front. So let's just say insert at the front. I don't have to find the previous or anything crazy like that. Otherwise, so if is empty, I'm going to insert at front, p new node. All right, and then if it was empty, but then I also need a p and is equal to p new node. All right. Else, I may have to rebalance these things in a second. Otherwise, I have more than one element. I'm going to insert at the end. How do I insert at the end? I need to figure out if there was a previous. That's where I'm going to have some trouble. So if there was a previous, so p end was already defined. Okay, my p end has already been identified if I have a non-empty list. If that's in fact the case, then I am going to attach the p end to this new node, set the new node to be p end, and I will need to set the previous, this new node I'm adding, I need to point it back to the previous endpoint. Oh wait, that's my IOU. So in this case, and now the previous. So in this case, I'm going to say p and set next and p new node. All right. My p new node set previous. Oh crap! I don't have a set previous. We're going to have a set previous, but what other possibilities are there? If there was no node there at all before, there was no p end, then I wouldn't do this. Okay. And my p-end in both of these cases, I'm going to have the next and the previous is going to be null. Okay, that seems reasonable. And p-end is equal. I'm going to change what my p-end is pointing to. P new node. Oh, I have an extra p in there. Okay. To do, because I know I'm going to have to go back to that. Okay, how about this is where the challenge might be the challenge part. I need to figure out how do I remove from the front? Well, I actually can call linked list remove from front. I could call it remove from back as well. So I'm going to remove from the front. That should be fine. And I need to figure out if the p-end was equal to the start, then I need to set I need to set. So if I had one element altogether, I need to just remove it. Let's not go much further than this. I want to just check my code before I start writing a whole lot of functions in here. So if I insert it at the if I insert the node at the if I'm removing the node from the front, then and there was only one node in total, what do I get? I have the p-end and p-start is equal to each other, right? The start and the end, same node. And in that case, I need to update my p-end. Otherwise, I don't need to touch my p-end. Okay, that seems reasonable. I could also remove the node, check this length or the size of my thing. Let's do that. That's more generalized. I like that. Okay, so if is empty. So after I did this, if it's empty, then p-end is equal to null. Otherwise, and then I'm going to return. This is actually a different code than I actually wrote yesterday, so this is going to be fun. We'll have to see how that goes. Let's build it, see if it compiles. Oh, one other thing I was playing around with. I'm not sure where I'm blanking just from yesterday where my video was with this. With the header files. I was suggesting at some point in time, maybe in the cut video, maybe not in the cut video, that one of the things you can do for your header files is to just put all your includes, all your the various libraries, various include statements you're going to have, and you're using namespace std, that sort of thing. Put that into one header file and include that one header file for all your CPP files. So I would like to point out I'm sort of doing that. So WLinkedList.h. Let's have a look at what WLinkedList.h is. That is, I had it reversed in my example before. I was trying to get the thing that everybody needed, like where all the header files are, like everybody needs linked list node. Every single one of these classes needs the class linked list node. And so I was thinking, let's put all of our includes there. But no, because I need to go in a particular order. What I want is one of the header files that they're going to be included anyways, but includes every other header file. They're only going to be included once. So if I include it in WLinkedList.h, and then linkedlist.h includes WLinkedList.h, linkedlist.cpp includes linkedlist.h, WLinkedList.h, linkedlist main includes WLinkedList.h. All of my various CPP files include WLinkedList.h. And what I get is the include statements are in a particular order that I know, all in one place. And so I don't get the weird case of like, well, maybe it works, maybe it doesn't work. It's one approach you can take. In case the header files are getting overwhelming and it's hard to keep track of the ordering effect, that's one way you could do it. Okay, let's have a look at what my code does. And I'm going to take a quick pause, because we should have more pauses in my videos. And then we're going to see what we get. All right, I had put a printf statement in here, so continue, and let's see what I have. All right, So I call this, by the way, my linked list is only a doubly linked list. Look what happens. I call linked list constructors, the linked list constructor, and then I call the doubly linked list constructor every time I make a doubly linked list. I call the parents constructor as well, because I need to set that stuff up as well. So I call the parents constructor, then my own constructor, and then when I destroy things, I call my own destructor. I start with my own destructor, and at the very end, I call the parents destructor. That way I know that how things are set up and taken down. It's set up and take down. So you put the tablecloth on, then you put the plates on. When you clean up the table, you take the plates off, then you take the tablecloth off. It has to go in that particular order, otherwise you get smashed plates. So notice what I have here. I'm going to make a bunch of nodes. So each time I've inserted something, I'm inserting -2, 17, 9, 21, and 0. They're being added to my linked list. Here they are. Sometimes at the front, sometimes at the back. So here are my 5 nodes with various sizes. I'm removing, I think, from the front and then from the back. My remove from the front is only the only one that's implemented so far. So instead of down to 3, it stays at 4, and it stays at 4 because I haven't implemented the remove from back yet. Okay, and then I think I have a remove from back one more time. No, I added 2 nodes, and then I remove from the back one more time. Okay, and then I called it the destructor. I need to implement this remove from back. So let me take a quick pause of the video, make sure it actually is recording properly, and then we're going to look at how we remove the node from the back, and then we're going to make a brand new class. So hold on a second.